just kidding. All right, algebra, this is 8-6, last lesson here, and example number 1. So you can see immediately, example number 1 is talking about an arithmetic sequence. So again, that laundry list of things should be running through your head. You know, common difference, which means constant rate of change. I almost wrote common ratio. There's a common difference, that constant rate of change, CROC, meaning this is linear, meaning it's going to look like a y equals mx plus b. All of that stuff is stuff that's not new to you. We've been using it. We've been doing this. Also, arithmetic, that common difference means that adding or subtracting. Oh, sorry. Oh my God. All right. So they tell me that the first term is -3 and the fourth term is -30. So whenever I'm doing these, I like to list them out along the side. A sub 0, because I know I'll need to find that. A sub 1, A sub 2, A sub 3, and the fourth term, A sub 4. All right, we don't know A sub 0, but they do tell us that the first term is -3, and they tell us that the fourth term is -30. So when you aren't given two terms that are consecutive or right in a row or right next to each other, you have to do a little bit of equation work and a little bit of math to find that pattern or to find that common difference in this case. So what a common difference mean, or what an arithmetic sequence means, is that there is some common difference, some d, that I am adding to get to the next term. So that means that if I have A sub 1, there's some unknown common difference that I can add to that will get me to A sub 2. Once I'm at A sub 2, I can add that common difference again, even though I don't know what it is. That's why I'm using that variable, and that will get me to A sub 3. Once I'm at A sub 3, I need to add that common difference one more time to get me to A sub 4. Now, careful here. Notice you're going to think that because there's two missing terms that you're only adding d twice, but that is not the case. That needs to get added 3 times. And this makes sense because if you have the first term and the fourth term, 1 minus 4, 4 minus 1 gives you that 3, which is why there should be 3 d's. So now from this, we're going to make the equation that if I take, we're going to start by finding... We're going to, let me just see here, we're going to make an equation to find what that common difference is. And that equation is going to look like -3 plus d plus d plus d equals -30. So I can kind of clean that up a little bit. -3 plus d plus d plus d would be 3d is equal to -30. Solve that. Get that variable isolated. Add 3 to both sides. -30 plus 3 is -27. Divide by 3 to get a common difference of -9. That common difference of -9 making sense because I see that I'm starting with -3 and my answer is getting more negative. So I'm subtracting 9. So -3 minus 9 would give me a -12. -12 minus 9 would get me that -21. And -21 minus 9 does get me that -30. Okay, so we need to find the 10th term, write a recursive rule, and an explicit equation. So much going on. So I've got enough right now to start my recursive rule. I'm going to do that in green. So my recursive rule is going to be equal to, remember, every single recursive rule starts out with a sub n is equal to a sub n minus 1. Because it's arithmetic, we have that plus d. We found our common difference to be -9, so I'm just going to throw that in, -9. But don't forget to give your first term. A sub 1 is equal to -3. So there is my recursive rule. Up next, I'm going to make that explicit equation, that y equals mx plus b. I already know that I have the m, or my slope, my common difference, of -9. So I'm going to turn that into a of n is equal to -9n instead of x. And then I just need to find the y-intercept. Remember, y-intercept is that a sub 0. And I'm just going to work backwards here. If I'm minusing 9 to get to the next term, going backwards from 9 would get me to a sub 0. Going backward. Doing the opposite of minusing 9, which would be adding 9, would get me my a sub 0. So a sub 0 is going to be -3 plus 9, which is 6. So my equation says a of n, or a sub n, equals -9n plus 6. This is my explicit equation. All right, and last but not least, we can use that explicit equation to find the 10th term. So a of 10 is equal to -9 times 10 plus 6. A of 10, or a sub 10 if you're using that notation, ends up being -84.